Welcome back, mathematicians. In this video, we are going to do more examples where we are solving radical equations. In our first example, we have the square root of the expression 5x plus 10 minus 2 is equal to x. Our first step when solving radical equations is to isolate the radical. So in this case, that means we are going to add 2 to both sides. This now gives us a new equation of the square root of 5x plus 10 is equal to x plus 2. Now we need to identify the index of the radical. Now it's not written, so it's assumed that the index is a value of 2. We are now going to raise both sides to the power of that index, which is 2, and simplify. On the left side, the power and the radical undo each other, leaving us with 5x plus 10. On the right side, we need to, first of all, it's actually important that we put parentheses around x plus 2 because you're raising the entire expression to the power of 2. And x plus 2 quantity squared really represents x plus 2 times x plus 2. Remember that power is repeated multiplication. Now we need to simplify that right side by applying the distributive property or FOIL. What we get when we FOIL it out, those two binomials, is x squared plus 4x plus 4. We now have a quadratic equation, and our goal is to solve this quadratic equation, which we can use any strategy that we choose. So we could complete the squares, we could also use the quadratic formula, or we could factor. Regardless, what I need to do is get one side equal to 0. To do this, I'm going to subtract 5x to both sides, and at the same time, I'm going to subtract 10 to both sides. This now gives me a new equation of 0 is equal to x squared minus x minus 6. Now I choose to factor this, so we would have 0 is equal to the factors of x minus 3 times x plus 2. Using the zero product property, I can then identify the two solutions as x equals 3 and x equals negative 2. Now we're not done yet because anytime we have a radical equation with an even index, we really need to check our solutions because it could be possible that one of these or both of these solutions actually does not satisfy the original equation. When that happens, that is called an extraneous solution. So let's check. Number one, we're going to check x is equal to positive 3. This means we would have 5 times 3 plus 10 under the radical minus 2 is equal to positive 3. We always use the original form of the equation. Now let's do our order of operations to simplify the left side. 5 times 3 is equal to 15. 15 plus 10 is 25. So we have the square root of 25 minus 2 is equal to 3. The square root of 25 is equal to 5. So we have 5 minus 2 is equal to 3. And 5 minus 2 is 3. And so this verifies that 3 is a true solution. Now let's repeat the same process for our second solution. And so number 2, we have a solution of x equals negative 2. So underneath the radical, I have 5 times negative 2 plus 10 minus 2 is equal to negative 2. Well, 5 times negative 2 is negative 10, and negative 10 plus 10 is equal to 0. So I have the square root of 0 minus 2 is equal to negative 2. Well, the square root of 0 is 0, so we have 0 minus 2 is equal to negative 2, which now gives me a difference of negative 2 is equal to negative 2. So we have now verified that both of these solutions are in fact true, and there are no extraneous solutions. Let's now go to our second example, and in our second example, we have x minus 4 raised to the 1/2 power is equal to 6. Now you might be thinking, this doesn't really look like a radical equation, but really it is, because anytime you have a rational exponent, it can be rewritten as a radical. So for example, in general, we'd say the nth root of x to the m power is really equal to x to the m over n. Well, in this case, 1/2 really means that what you have is the square root of x minus 4, because the index is 2 and the power of x minus 4 is equal to 1. So what we really have, in fact, is a square root, just not written in that form. Well, the first thing we want to do is isolate the radical, or in this case, isolate the x minus 4 raised to the 1/2 power. Well, there's nothing on the left side outside of that, so that step is already done for us. Let's move on. The second step then is to raise each side to the index. Well, in this case, that means raising both sides to the reciprocal of the rational exponent. So 2 over 1 or just 2. When we raise the left side to the 2 over 1 power, or just second power, that undoes the 1/2 power. And that is also a property of exponents, because it's x to the m raised to the nth power is equal to x to the m times n. So in other words, what we're really doing is taking the 1/2 power times the 2 over 1 power, which really just results in a power of 1. So we get x minus 4 raised to the first power, or just x minus 4. On the right side, we have 6 squared, which is 36. And then finally, the last step is to add 4 to both sides. And so this gives us a solution of x is equal to 40. Now, as we did in the last example, we should check our solution. So let's go ahead and take 40 minus 4 raised to the 1/2 power is equal to 6. 40 minus 4 is 36 raised to the 1/2 power. And if you prefer at this point to not write it as a rational exponent, but instead to write it as a radical, that's fine. This is really just the same as the square root of 36. And the square root of 36 is in fact 6. So it does check our solution. It does actually validate that our solution is true and not extraneous. So x is equal to 40 in this case. All right, guys, good luck.